All right, I'm going to talk to y'all today about Boyle's Law, which is a thermodynamic principle, and I'm in group 1, and I'm going to do a 6-minute talk. So background, Robert Boyle is the one who founded Boyle's Law. Obviously, it's based on his last name. He was a founder of modern chemistry. I think his background was actually as a chemist, and he's also an inventor, philosopher, alchemist, and things like that. He lived during the 1600s in the United Kingdom, and fun fact, I think he was actually knighted for his inventions. That's pretty cool. So how it was discovered. So he did a lot of work of testing different gases in enclosed volumes and in like J tubes, which is shown here. So basically this setup shows how you have one end of the tube is fixed, the other end is open to whatever gas you're going to put in it. And what he found on a lot of this testing is that gases are elastic, meaning they return to their original shape after being stretched, meaning that they're compressible. And the way it was actually found, the gas that was used for Boyle's Law was mercury. So the results of his experiment showed that pressure times volume, it equals a proportionality constant. So what happened was he put the mercury to the free end, and at different volumes and pressures that were put in, he found that the constant was the same. So as you can see, when the volume of mercury in the tube was 48, whatever unit that was, the pressure ended up being that, and it's right around 1400. So it stays the same, and I'm going to talk about why that's important in a second. So what this means. So it's easy to think pressure times volume equals a constant, but what it really means is that pressure and volume are inversely related. So as pressure goes up, volume is going to go down, and as volume goes up, pressure is going to go down. Or as you can see, P1 times V1 equals P2 times V2. And the actual law written whenever it was formatted states a gas in a closed container with constant temperature and mass will have a pressure inversely proportional to volume. So obviously condition for this is that the mass and the temperature stays the same, so they're constant. Graphically, pressure and volume are inversely related, but it makes more sense to view it from 1 over volume. So as I already talked about, it's a straight line. As pressure goes up, volume goes down, volume goes up, pressure goes down. And I got a few examples for y'all. So the first one, visually you can see in a piston is, so this is important because obviously cars use piston, a 4-stroke uses a 6 or 8 piston cylinder setup. So as the piston goes up, the volume increases, and the pressure decreases. As it goes down, it compresses in the compression stroke. The volume decreases and the pressure increases. And this is important because you want the highest pressure right before your combustion actually happens. Yeah. So my first example is a balloon. So everyone knows the example of static electricity and how a balloon works, but it can also be understood from the sense of Boyle's Law. And so take a fully blown up balloon and you start to squeeze it. So whenever it's fully blown up, the volume is at its maximum volume it's going to have. So as you start decreasing the volume, the pressure is going to increase. So it's going to reach a critical point at a certain stage where the volume gets so low and the pressure gets too high for the enclosed volume that it's going to pop. And this can be shown, in a balloon, in a combustion chamber, anything. When the pressure gets too high in something, it can explode and something bad can happen. Next example. So originally when you think of Boyle's Law, you think it's just a very basic volume and pressure inversely related. But it can actually be applied, and it's extremely life and death important. So the best example is scuba diving. So the best way to explain this is, I'll start off by saying the golden rule in this is you never want to hold your breath. And I'm going to go into that next slide, but so in generality, when descending, your body and your lungs take up less volume overall. So the pressure on it's going to increase. Also, you know, when you go lower in water, in a liquid, the pressure is going to increase. Everyone knows that. And this is also seen by gas bubbles going to the surface on the opposite end when you ascend. And I have some numbers to it in a second, which is going to make a lot more sense. So take a diver at 30 meters underwater. This corresponds to 4 atmospheres of pressure, which is the 3 atmospheres underwater and the 1 added up from the surface. So P1 times V1 equals P2 times V2, okay? So take a diver at 30 meters. Pressure at that, so pressure at the bottom, at that level is going to be 4 atmospheres. The volume of the enclosed, of their actual lung capacity is 1 liter, right? So at the surface, the pressure is 1 atmosphere. What does this mean? The volume of that their air takes up in their lung at the surface is going to be 4 times its typical volume. So if you hold your breath, you could literally die. You'll get a gas embolism in your lungs. So what you want to do is you want to breathe out, which is releasing volume from your lungs. And consequently, if you take a breath at the surface, pressure is 1 atmosphere, volume is 1 liter. You know the pressure at that 30 meter mark is 4 atmospheres. So the volume in your lung is going to be 1/4 at that 30 meter mark. So this is obviously extremely dangerous as well. This is why when descending, you try to you breathe in when descending because you want the volume in your lungs to increase and level out. So those are my examples, and that's the best way I can explain Boyle's law to a real world example. Thank you.